Hey class, today's video, what we're going to do is I'm going to show you guys how to perform this synthesis of aspirin lab. Okay, this is number 5 on your lab manual. So synthesis of aspirin, that's the lab that we'll be doing in this particular video. Now, there are several concepts I want to show you guys in this particular lab. In the sense that, when you're describing a reaction, what happened is you'll write it in such a way that you have the reactants, which are the beginning material, and then process, which is the arrow, and then the products, okay? And there are several ways of doing these things. In 151, we typically use what they call the molecular formula. That's these expressions right there. And what it does is shows you how many of each element are inside a molecule of a given compound, okay? Now, however, when you get to organic, what happens is that you encounter a lot of things called isomers. That means they have the same kind of chemical formula, but however, the elements are bonded differently. In that case, it's to be less ambiguous, you would use what they call the structural formula, which are these diagrams that shows each of the atoms and how they're bonded, okay? And because of the fact that they are bonded differently, they have different physical as well as chemical properties, okay? And then if you notice that an additional detail here is that on top of the arrow, there's a compound right there. That's usually known as the catalyst or condition. And then of course, if you put a triangle on the bottom, which I forgot to put in the lab manual, that means they heat it, okay? Now, so therefore, we're going to go from salicylic acid, which is like a compound W, a Neutrogena anti-wash, that's what that's for, reacting with a corrosive substance called acetic anhydride. And what happens, you cook it with the help of a phosphoric acid, and what you'll get is that this is aspirin right there, which is technically called acetylsalicylic acid, yeah? And then of course you'll also get acetic acid. So therefore in lab, don't be surprised that the lab's gonna smell like a pickle factory afterward. So that's the reason, okay? Now, having described this, there's 3 major concepts that we're trying to teach you guys in this lab. And of course the thing is, you'll be using this thing in 152 as well as organic. And of course, when I used to be in industry, we use that a lot. You guys are working in grams, we were working in tons of stuff, but the concept is the same, okay? Now what you got over here is this. The first concept is called the theoretical yield. Theoretical yield is the maximum amount of products that you can produce based on how much reactants you started with, okay? And that's a very important concept. You should not be able to make more than that for that given product, because if you do, then you have just violated the law of mass conservation. And the thing is, in industry, what happened is that if you predict a certain amount of theoretical yield and then your mass is a little bit bigger, what it means that you probably have contaminated stuff, okay? Now, the second concept that we're going to teach you guys is the limiting reagent. That is the reactant, the starting material that got completely used up. And once it's completely used up, it stops the reaction, and thus it limits the amount of product you can make, yeah? And if you were doing industry, what happened? You make sure that that guy, the most expensive one, reactant would be the limiting reagent. Otherwise, you'll be wasting it, okay? And then the third concept is known as the percent yield. What it does, it describes the efficiency of your synthetic process, okay? So the thing is that now it goes somewhere between 0% to 100%. Now, I've never seen 0%, that means you didn't do anything. And in the 30 years I've been out there, I've never seen 100%. It's never kind of perfect like that. But however, if you're in the high 80s and 90s, you're pretty good. On the other hand, if your synthetic process is in the 10s and 20%, man, that means your process is not very good. In that case, you might have to design your thing and keep scrubbing, right? So anyway, those are the concepts we'll be teaching. Okay. All right, class. I've just explained the concept. Now, the next thing is I'm going to show you guys what kind of equipment you're going to be needing for this particular lab, okay? So here we go. Now, what happened is you'll need some salicylic acid, okay? That's and then of course it should be parked by an analytical balance, okay? Hey, you guys make sure you guys zero the balance. Use the same balance each time, and also zero the balance every time you use it, yeah? And of course there'll be a stack of bolts right there that goes with that, okay? So this is for the weighing. Now what you got over here is the setup is divided into 6 parts here. What you got over here is the first part right here is that you have a 125 milliliter Erlenmeyer flask with a test tube, okay? Now, this could be the container could be anything. The only purpose is for sending up the test tube. Okay, this is for getting the salicylic acid plus the acetic anhydride plus the phosphoric acid. Okay, now the next part is this. I'll show you how to do this when we go along. What you got here is you have a pole with a clamp and a 250 milliliter beaker right here. This is for putting tap water, and there's a hot plate. This is for cooking. Hey, you remember when your handle was down here, never touch the white spot. And of course, the relevant knob is this one right here, the one on the left for heating. Okay, don't play with the other one. All right, so therefore that's cooking. Now the next part is for stopping the reaction. That's when you need a long stem, disposable pipette, a stirring rod, and also a small graduated cylinder. Okay, this is for stopping the reaction. Now the next thing is to chill the product after you make it. So therefore you have a tub full of ice. Go get some ice, and then later on you need to put some water in. Okay, so that way you establish the equilibrium. You also should have a 250 milliliter beaker with deionized water or distilled water. Okay, this will be the first part, but right now I'm just showing you guys the equipment. Okay, so this is for chilling and crystallizing your product, and then the next part here is for drying. So what you got here is you have a filtration flask with a hose, and what happens, donut right there is to hold it down so that when you're working it doesn't flip on you. And then here's a Buchner funnel. Okay, it should be able to, it's separable like that. Okay, and then you should also get yourself one of the Wattman number 4 70 millimeter filter paper. Okay, that goes in there. Now you guys, don't waste this. Right now we're running low, so get only one per group. And then also you should also have a squirt bottle right here for wetting the filter paper when we get in there. Now, associated with this, what happens is that we have a vacuum valve right there. What happens, that's for making a vacuum so that you can suck the liquid out, and also for drying. Okay. Now the last bit of it is this one right here. You have a watch glass. That's for holding your product. Okay, for the next time. Also a forceps, aka tweezer, as well as a spatula. Okay, so these are the appropriate equipment for the lab for the day. Okay, so this will be one more complicated synthesis for the semester. Hey, enjoy. When you go to organic, there'll be a lot more stuff. Okay. All right, class. Now that you gather all the equipment that's necessary, what you want to do is this. The first thing you want to do is that before you get the other stuff, is that, you know that ice right there? Go to the sink and put some water into it. Because what you want is that you want to form a slush in there. Because what you want to do is that you want to have an equilibrium. But you have a coexistence of ice plus liquid water. In that case, this ice bath will maintain at 0 degrees Celsius. Okay? And then what you do is to park in this place, and then stick that 250 milliliter distilled water and park it in there. Okay? You want to chill that. So that this will take the longest. That's why I'm doing that one first. Okay? So what I'm going to do is I'm going to go get the, I'm going to go weigh the thing out in just a bit. All right, class. Now, we just put the water into the ice. Now, the next thing is we need to get the appropriate amount of material. So if you look on page 41 of your lab manual, the procedure is such like you have to get the mass of the flask, okay, and the empty test tube. Afterward, you go weigh the amount of a salicylic acid, park it into the test tube and weigh that, and then and then of course while you're doing it, you might as well also get a filter paper and go weigh that, yeah? So what I'm going to do is I'm going to gather the stuff. I'm going to get the flask weighed first, okay? So, there we go. Got the flask with the test tube. Go to the analytical balance. Make sure you zero that. And then what we do is I'm going to go to the top. It might be coming in this time like that. So in that case, park it in like that. And the test tube should be below the window, so you'll be fine. Okay, so therefore close the window and then record this particular mass, okay? That would be your mass of flask and empty test tube, okay? Now, the next thing you want to do is this. Take this guy out. Now, this is what I'm going to call the salicylic acid method. Because what you're going to do is you're going to guesstimate 0.4 blah blah grams of salicylic acid and transfer it into the test tube, okay? But however, don't record the next number. Because so what happens is that something gets stuck here, and that's not a good number. What's important, what's in there, yeah? So here we go, here's a boat, and what I'm gonna do is that, park it in there, and there's a number, but you don't care about that number. In that case, push 0, okay? So that sets that at 0. Now what you then do is that, here's the salicylic acid. You guys be careful with this. This stuff is corrosive, okay? So what you do is that, open that up. Now here's the thing, when you're weighing things like that, don't go around like that. So what you do is that you open up both windows, okay? And then what you then do is to stick the bottle through the other one hand, and then use a spatula on the other hand. And what you're gonna do is you're gonna scoop in till it hits about 0.4 something. So, one. Wait, okay, that's point. Okay. Okay, so I got about 0.5 something. Okay, that's pretty good. However, do not take that number, okay? So you're estimating this much. So what you then do is to take that guy out. It's a good habit to close it. And what you then do is that, shake it, and here's a test tube. What you do is put the spout right there and shake the powder in, okay? Try to get as much as you can, okay? Now you notice that there's some powder that's stuck right there. That's why I did not record that number, okay? So, what's important is what's in here. So it should be about like that. Okay, now park it back in here. Now zero the balance again. Okay, you just zeroed it. In that case, park it back in here. Okay, record this mass. Okay, so in that case, there's your mass of the flask, test tube, as well as salicylic acid. Okay, so what you do is that you subtract the previous number from this one to get the exact amount of salicylic acid that's in the test tube. Okay, that's what's important. So take that out, and since I'm here, what I should do is just go weigh the filter. So what you do is grab the filter. Okay, make sure you zero it again just for insurance. And then this time go this way because it's a little short thing in that case. Okay, there's your mass of the filter paper. Yeah, that's right there. In that case, all of your weighing is done for now. Okay. All right, class. We just got the salicylic acid. Now what we need to do is go at the acetic anhydride as well as the phosphoric acid. Okay? Now, typically in my class, you'll bring over and I'll help you with this thing. But hey, you guys, when you guys need to do this, be very careful. The acetic anhydride will dehydrate you. So therefore, gloves on, goggles on, and also stand arm's length, that's not your friend. So in that case, what you do is that, squeeze, see right there? The mark on the pipette tells you how much put in, so in that case, okay, we'll go, okay, let's get rid of some of it. You don't want too much, you want just about enough. Okay, that's about right. Okay, so in that case, what you then do is this. Go to a test tube, squirt that in there. Okay, next thing, you need the phosphoric acid. So what you do is that squeeze, put in, you only need about 2 or 3 drops in there. So in that case, 1, 2, 3, 4. Okay, it's good enough. Okay, let's get that in there. Close both bottles. That's a good habit. Always close it afterward, okay? And then what you want to do is this. You want to just kind of wag the test tube a little to mix it. So therefore, go take it out and go like this. Wag, just like a dog's tail. Wag. Okay, like that. And then you take that to your station, okay? Don't do this. Because what happens, you'll get that stuff on your hand. Understand? So, all right. So now you got the salicylic acid, and you put in 0.4. Let's see. You have 0.4 grams of salicylic acid, you got about 0.9 milliliter of acetic anhydride, and you got about, say, 3 or 4 drops of phosphoric acid, okay? So in that case, we're done with the mixing. The next step would be cooking, okay? I'll be back when we start cooking. All right, class, we're back at our station, with that flask with the test tube with the stuff. Now next thing is this, we're going to prepare to cook, okay? So what we're going to do is this, the speaker right here, go and get some tap water. Don't waste the still water in this thing. What you want to do is maybe fill it about half full or something like that. Yeah, sort of like that, okay? What you do is that, hey you guys notice that nothing's plugged in, okay? That's for safety purpose. Thing is that don't turn anything on until you finish with the setup, okay? So here you go, you park the test tube like that, excuse me, the beaker with the water like that, and then here's the test tube. What you want to do is clamp it on the clamp. Oh, by the way, it should have a lip. You have the test tube? That way it can sit safely on the clamp. So pinch it like that, tighten it. And what you then do is move your setup. And what you want to do is bring it down. Okay, so that so that your test tube is maybe about half an inch from the bottom or something like that. Okay, so it's kind of set up. Now what you want to do is that, in that case, ready for plug in. So, like that. And then the left knob, turn it clockwise all the way. And you'll see a green light right there. So what we'll do is that now let it cook, okay? So the thing is that this is going to be a lapse time video in the sense that we'll let it heat up, and once it starts boiling, then what you then do is to go and cook it for about say 10 minutes, okay? So therefore your clock for the cooking starts after it boils. Now the thing is that typically you want to put a thermometer in here, but however in Phoenix the boiling point is about say 98, it's about right. So therefore that's why I didn't bother to put a thermometer there, okay? All right, so therefore, when it starts boiling and starts cooking, I'll come back, okay? All right, class. Look like we waited a bit, and right now it's boiling. It has been boiling. And the thing is that you're supposed to cook this for about 10 minutes or so. Now, what I did was that this thing has been cooking for about, say, 5 minutes or so. Now, what happened is that if it's clear, then perfect, yeah? But if not, what you do is this. Stir, yeah? But hey, guys. Make sure that the stirring rod is dry before you put it in there, okay? So therefore, that's what you do. And what you want to do is this. You're going to stick it in there, and you're going to stir it this way. Don't jab like that, okay? So stir it this way. So here we go. Arm's length away. What you do is it's dry, and then what you do is go in there and stir. Okay. So it looks like all that thing's been dissolved. So let it cook another 5. Hey, you guys, this particular thing right here, park at the edge of the sink. Ooh, it smells like vinegar. All right, so what you want to do is that keep it cooking for another 5 minutes. Okay, I'll come back when it's done. All right, class, we just finished cooking. So what you want to do is this, make sure, shut the guy off. So, okay, the green light goes off. Now the next thing is this. Before you stop the reaction by adding water, you want to lift it up and let it wait about a minute or so. Otherwise, it can go a little violent. So this is what you do. Okay, like this. Pick it up. And then what you then do is lift it up above. Okay? Wait about a minute or so. Now, meanwhile, what you want to do is this. Go and squirt about, say, 5 milliliters of water or something like that. This is a 10 milliliter graduated cylinder, so about 5 like that. And what you want to do is get ready. So you need this disposable pipette, long stem, so you can get an arm's length away from this, and you'll be adding water once it's ready. Okay? I'm going to wait or so. All right, we just waited a minute or so. Now what you want to do is this. You're going to add the water in there drop-wise. Do not squirt, okay? So the thing is, I'm going to show you guys. When we mean drop, it means drop, 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 not squirt. Understand? When you squirt like that, what happened is that it can go a little bit, reaction can be fast. All right, so here we go. So what you want to do is that here's a 5, and what you want to do is like this. And what you want to do is at arm's length away from this thing, and you want to put the tip in there. Do not stand like this, because you don't want that thing splatter up at you, just in case. So in that case, here we go. Now, if it's my class, what happens, I would coach the students through. But this is what you do. Go drop, 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 sort of like that, okay? And then what you do is you watch for it in the sense that you do not want this thing to be boiling. So in that case, oh, it's fizzing right there, okay? So I'm gonna keep a little bit more. Drop, drop. Now that it's then you can go slowly add them in, yes? And you notice that I'm keeping it about arm's length away from this thing. This is not your friend, okay? In fact, this is the part of the lab that kind of wakes me up at night about you guys. So in that case, since I was able to do it, now move it at the same rate as last time. So in that case, here we go. Drop. But you notice that my hand is not over the test tube, understand? And pretty soon you'll get some white stuff coming out. That's your aspirin trying to come out. So here we go. I'm putting it in dropwise, and then of course the final one. Okay, I'm gonna squirt, and then the last bit. There we go. You notice it's like that, yeah? I'm keeping my body away from this. Okay, so in that case we're good. Hey, not bad. No violence. Okay, next thing is this. Take the setup off. Okay, and then what you want to do is that wag it a little bit. Ooh, it's already coming out. That's pretty damn good. All right, and then what you want to do is this. Park it in like that. Okay, so let the clamp be part of your holder, okay? Because some of the guys, they don't listen to me. They just stick it in the ice and Bruce will spill over. Now I have to start the lab over. So what I'm going to do is this. We're going to wait for the aspirin to precipitate out, okay, to crystallize out. So basically what happens initially, you ever done a snow globe? Shake it like that, and there's little flicks coming out? That's what it should look like. And then afterward, what you then do is to, once you got a lot more, now the thing is I typically wait about say 15 minutes after the initial. Now, the longer the better, but however, you may not want to be that long. Okay, so in that case, we'll wait about say 10 to 15 minutes and watch for it to crystallize out. When that time comes, I'll come back. Okay. All right, class. You know, while you guys are waiting for the aspirin to crystallize out, test your filtration flask. So what you want to do is this. You got your filtration flask right there, the donut, you got the Buchner funnel. Now what I want you to do is that just park it flat. You know, the filter paper, park it in there. And then what you do, take the squirt bottle with you, plug it into the valve, the spigot that has a vac, okay, the yellow one. Now what you want to do is this. You're going to open up the valve this way, okay? And then what you want to do is pour a little bit of water in there and set up just a little bit. Oh yeah, okay? So you see the water squirting through? That tells you that the vacuum is okay, yeah? All right, so in that case, meanwhile, what you want to do is this. You want to tamp down the filter paper. So what you do is use a squirt bottle to wet the filter, and then what you want to do is that kind of push down on the edges, okay, of the filter paper. Because what you want is you want the liquid to go through the paper, and you want the aspirin to get stuck on the paper. You don't want it to give it away, go around, okay? So there we go. All right, tap, don't tear, okay? All right, so in that case, it looks like we're good, yeah? So when it's ready, what you want to do is something like this. See? All right, it's ready, okay? Oh, it's kind of foggy. So in that case, what you want to do is this. It's still on. Take the, separate the test tube from the clamp, okay? Loosen it up and go like that, okay? Now what you want to do is this. Oh, it's stuck. So in that case, what you want to do is go fill it about say 2/3 fill with that cold distilled water right there. And then what you do is break it up using the stirring rod, yeah? So go, okay? The secret for success is being quick about it, okay? So here we go. So hold it like that, and then what you do is this. What? Yeah! And what happened is this, the white powder's right there, and then you got the clear liquid. So in that case, just do a few more times until you get it all, okay? Like that. See, basically what you're doing is you're taking the aspirin out, and you're also rinsing with distilled water to kind of wash off a lot of the acetic acid. Ooh, yeah, one more time. All right. All right, so in that case, I'll put that back over here. You're done with the test tube. So in that case, what you want to do is that keep the vacuum running. Okay, what happens, you'll see that they're dripping. You want to go keep it for another 15 minutes. That way you can kind of air dry the stuff, so that when you have to wait, you don't have to wait so long. So in that case, keep it on, okay? That way you can air dry the aspirin for about, say, 15 minutes. All right, we'll come back when it's that time. Okay. All right, class, we just finished drying the stuff. So in that case, what you want to do is hold on to the flask and then shut the valve, okay? Hey, you guys, make sure you do, because if we run this thing, we're gonna burn the pump. So therefore, shut the vacuum. Now the next thing you can do is this. That'll allow you to pull this thing out. And then what you then do is this. Separate by twisting, okay? Like that. The goodies up here. Now what you then do is that use the spatula to try to pry the edges of the filter paper. Okay, and then what happens is you're going to try to lift it up and then use a tweezer and try to slide it. Oh boy, I suck at this one, so I hope it works. So in that case, what I did was I kind of pry up the paper. Okay, so in that case, get the tweezer in there. Yep. And then what you want to do is that slide it across like that. Hey, it works. All right, so in that case, now you have some semi-dried aspirin on a filter paper, and then that's on top of a watch glass. Now what you want to do is that before you go home that time, what you do is this, paper like this, and what you want to do is you want loosely covered. You don't want this thing touching, okay? So for sort of like that, yeah, put your name on the paper, yeah? And then what you then do, we'll store it, and then we're done for the first week, yeah? Now, when it comes to the second week, when you're measuring the mass, what you want to do is, I'm going to pretend that it's dry. We should do this, but no way. But if which one is dry, what you then do is you come in, zero the balance, and then what you want to do is that, like this, yeah? Zero the balance, and then what you want to do is get the tweezer and pull it across, and then put the tweezer across, and then that'll be weigh that, and it'll be the mass of your filter paper plus aspirin, okay? That's how you do that. Here's one thing, some students will go like that, just stick that in there, that's how you get a 3,000% yield, because you have now got the watch glass in there that you did not account for last time, okay? So anyway, we just did the first week. Second week, when you come in, and this is dry, zero the balance, open the door, watch glass in one hand, and then what you do is that you get the tweezer and pull the paper, and then there's your mass. That'll be your mass of your aspirin plus filter paper, okay? So in that case, hey, yippee-yay, we're done.